Okay, so now let's see a very beautiful and conceptual problem in motion in one dimension. Uh, let's see the question first. A point moves rectilinearly with deceleration which depends on the velocity v of the particle as a equal to k root v, where k is a positive constant. At the initial moment, the velocity is equal to v naught. What distance will it cover before it stops, and at what time it will take to cover that distance? So first thing that we can see here is that the acceleration of the particle is not constant. Here we can see that the acceleration of the particle is a function of velocity. What is the acceleration given in the question? A equal to k root v. Since acceleration depends on velocity, that is, acceleration is not constant. With change in velocity, acceleration will also change. So we can't apply kinematic equations in this case. So we will go with the integration part. But my dear, the first thing that we'll see, we have to see here is that in the question it is given that the particle is decelerating, not accelerating, it is decelerating. Then therefore we will put a minus sign here. To solve the question, we will put a minus sign because we have to see the sign also. So A equal to minus k root v, minus because the particle is decelerating and not accelerating. Now, what is acceleration? Acceleration is equal to v dv by dx. In place of acceleration, we can write v dv by dx. This is equal to minus k root v. Now, what we will do? All the v terms we will bring one side. So v by root v and dv equal to minus k into dx. Simplify it further. So it is equal to root v dv equal to minus k dx. Uh, what we will do further? We will integrate. We will integrate with the given values. Okay, here. So k is constant. So we'll bring it outside the integration. Now in the question it is given that when x equal to 0, the velocity of the particle is v naught. And when x equal to x, we are assuming that the velocity of the particle is v. Okay, so now I'm going to integrate it. Now I'm going to integrate it. Okay, yes, it's clear. So if I will integrate it, what I will get? If I will integrate it, what I will get? Let's see here. So this is equal to uh, v to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 and put it inside the bracket. What are the limits we have? Lower limit we have v naught, upper limit is v, and this is equal to what? This is equal to minus k. Integration of dx is x and the limits are 0 and lower limit is 0 and upper limit is x. Now, this is equal to what? This is equal to 2 by 3. 2 by 3 and what is here? V to the power 3 by 2. V to the power 3 by 2. And the limits are v naught, v minus k. Okay, for the x part, I am going to put the limits. First, put the upper limit, that is x minus 0. Now, in the left side, I am going to put the limits. First, put the upper limit in place of v. We will write v. So, v to the power 2 by 3. Sorry, 3 by 2 minus. Now, put the lower limit v naught to the power 3 by 2. So, and left hand side, right hand side, what we got minus k into x. So after integrating, we got this is our relation. This is our relation. Now in the question, it is given that when the particle, let's see the question first. here we can see that initial moment, what distance will it cover before it stops? Before it stops means the final velocity becomes 0. And when the final velocity becomes 0, we have to find the value of x. Okay. So now, when the final value, that is, according to the question, when final velocity is 0, we have to find the value of x. What will be the value of x when the velocity will become 0 or when the particle will come at rest? So in this equation, I'm going to put the value of v equal to 0. Let's see here. So 2 by 3, I put v equal to 0 here. So this part 0 minus v naught to the power 3 by 2 uh, minus k into x. Okay, I am assuming that at x equal to x naught, now after covering a distance x naught, the velocity of the particle becomes 0. So in place of x, I will put x naught here. So this is x naught. Yes. Now, yes. So now this minus minus will cancel out both sides. So what we got? We got that from here. What we got, that is x naught equal to 2 by 3k v naught to the power 3 by 2. So this is the value of distance that the particle will cover before coming to rest. Now we are going to do the second part of the question, and second part is more beautiful compared to the first one. In the second part, what would find at what time it will take to cover that distance. That is, the particle will take what time to cover a distance 2 by 3k v naught to the power 3 by 2. We have to find that after what time the particle will cover this particular distance. Okay. So again we will do the same thing. We know that uh, what is the acceleration given? Acceleration is given minus k into root v. And now we have to find time. So we will use acceleration equal to dv by dt, and this is equal to minus k into root v. Again I will do the same thing. First I will bring the velocity term one side, minus k into dt. Now after it, what I will do, I will integrate it both side, put the integration sign. Now when time was 0, the velocity was v naught, and after time t, I'm assuming that the velocity is v. Now again we are going to integrate this part. If we will integrate it, what we will get? We will get first v to the power minus half plus 1 by minus half plus 1. Now inside the, what is the lower limit? Lower limit is v naught and the upper limit is v. To the right side we have minus k into t. Okay, so what we got here, my dear, we got that v to the power 2 will come here. So yes, v to the power half. Okay, so we will get v to the power half, v to the power 1 by 2, and 2 will comes up and put the limit, lower limit v naught, upper limit v, minus k into t, this side. Now wait 1 minute. Yes, integration of dt here is dt and with limit 0 to t. Now, so again, now put the limits here. So what we will get? 2. We put the upper limit first. So v to the power 1 by 2. Put the lower limit tau, v naught to the power 1 by 2 minus k into t. Okay. So I am assuming that after time, when the velocity of the particle is 0, the time taken to cover the distance is t naught. So after time t naught, the velocity of the particle becomes 0. So what I will do, in this equation, I will put v, in place of v, I will put 0, and in place of t, I will put t naught. Okay, so so 2, what is v? 0, v naught to the power 1 by 2 minus k, what is t? T is t naught. So what we got? We got what T naught we got? T naught we got 2 root V naught by 2 root V naught by K. Okay. So we got the time and we got the velocity. Okay. I hope you understood the concept behind it. Okay. Thank you.